So in this video, we're going to continue with our discussion of distance vector routing protocols. We're going to talk about some of the loop prevention mechanisms built into distance vector routing protocols. Now, of course, any routing protocol can create routing loops if they're not properly configured or if something happens to the network. However, since distance vector protocols don't actually maintain a topology map in every router, then the distance vector routing protocol doesn't know what links are in what location in the network. And because they simply don't know what links are located throughout the network, they are more likely to create loops than their link state cousins. Now, I'll be perfectly honest, most of the looping issues that you run into with distance vector routing protocols depend on a series of unfortunate events to distribute incorrect routing information between the routers in the routing domain. And as you'll see as we go through the different scenarios, most of these unfortunate events are simply timing issues. However, if you configure the loop prevention features that we describe in this video, most of which are on by default, by the way, you will greatly reduce the possibility that a loop will occur. Now, can you prevent a routing loop entirely? No, you'll never be able to completely prevent routing loops, even with link state protocols or some of the more advanced EGP protocols like BGP. However, if the prevention mechanisms are built into the protocol, it's only a wise and prudent course of action to turn it on. So the first feature that we're going to talk about is route poisoning. And with route poisoning, you can signal other routers that a link has failed. Now, every routing protocol does this, obviously. It wouldn't be much of a routing protocol if it couldn't signal its neighbors that, hey, this route's down, don't send the traffic my way. However, distance vector routing protocols do route poisoning a little differently. Now, route poisoning is the default method of advertising that a link is no longer available. In other words, you don't have to turn on route poisoning. It's just there. It's part of the protocol. And really, we only discuss it as a precursor to the loop prevention technologies that are later on in this slide deck. Now, when an interface fails, routes for that interface are advertised with an infinity metric. Now, obviously, you can't count to infinity because infinity is infinity. You can't ever get there. However, distance vector route protocols have a specific metric that they define as infinity, and it's different for every distance vector routing protocol. RIP advertises infinite routes with a metric of 16. When a route fails, a router tells each of its neighbors, hey, this route is 16 hops away. And the router that receives that route update interprets that 16-hop route as to say it's completely unavailable, it's infinite, I'll never get there. Now, at least in the case of RIP, when a router receives this infinite route, it marks the route as possibly down in the routing table, and if the route does not come back up in a specified period of time, the route is actually removed from the routing table. So let's move on to the first looping issue you could run into in distance vector networks, and that is counting to infinity on a single link. Now, again, you won't actually count to infinity, you'll just count to 16, but the net effect is pretty much the same. So let's assume we have a pretty simple network here, two routers, one link, each with two networks on the other end of this router. Then say something happens and this link goes down, someone unplugs the cable or whatever happens. Well, per the route poisoning mechanism, this router 2 automatically starts advertising a metric 16 route for that network, this 10210/24, to router 1. However, if router 1 at the same time advertises that same network back to router 2, it says, hey, I've got a metric 2 route to this 10210/24 network. Well, router 2 now says, well, hey, I used to have a route to that network, but I don't have it anymore. You must have it. So I'm going to update my route table over here on router 2 to say I have a metric 2 route to this 10210 network, and it's going through router 1. So in its next route update, router 2 advertises this network with a metric 3 back to router 1. After 30 seconds, router 1 will say, hey, I've got a metric 3 route to this network. I'm going to advertise it back to router 2, and so on and so forth until both of these metrics get up to 16, at which point the route is finally marked as unavailable and falls out of the routing table. So how do you fix that? Well, in distance vector routing protocols, the solution to that is called split horizon. And simply put, routes learned on an interface don't need to be advertised back out the same interface. To go back to this example, router 1 learns the route to this 10210 network from router 2 on this serial interface or Ethernet or whatever. Split horizons turned on, I don't need to advertise back this network to this router because that's the one I learned it from. To be honest, it's very much like kids in the schoolyard. In this example, Fred knows a secret and tells it to Sally. Now, Sally knows this secret and she wants to pass it on to everyone, but she's not going to turn right around and tell Fred the same secret because Fred is where she learned it from. She goes over to Jane and Bobby and tells them the secret. At which point, Jane and Bobby don't turn around and tell Sally the secret they've just learned. They pass it on to everyone else, and that's how split horizon works in a distance vector network. Now, Cisco routers also use two other features to prevent counting to infinity, whether that's on a single link or on a redundant network. The first is called triggered updates. Now, if you'll recall from our initial discussion of distance vector routing protocols, the distance vector algorithm sends its entire routing table out to all of the connected routers every 30 seconds. However, in the case of a failed route, Cisco routers will send a partial route update immediately upon the link failing instead of waiting for the next 30-second update. And this kind of defeats the whole timing issue that's the root of a lot of these counting to infinity issues. The second feature that Cisco routers use is called poison reverse. And in this case, when I learn a failed route, whether it's locally or from another router, I'm going to suspend all my split horizon rules and I'm going to advertise that poisoned route out to everyone. And that ensures that all of my neighbor routers know that this route is poisoned no matter which router you learn it from. You can't get there from here at all. We'll continue our discussion of distance vector loop prevention in the next video.